An elevator cable with 18,000 newtons of tension pulls on an elevator car which has a mass of 2,000 kilograms. Draw a free body diagram and determine the acceleration of the elevator car. So, as we know, elevators, we can picture the situation, elevators always go up and down. So when we think about the forces, well, of course, there's always weight, or the force of gravity on anything. Okay, now this elevator is being held up by this rope, by this cable, which has a tension up of 18,000 newtons. So we're going to go ahead and jot that down. Now, to find the acceleration of the elevator car, to find acceleration, we know we need the net force, because F net is equal to mass times acceleration. And we can think about this as kind of like a tug of war. Tension is pulling up, force of gravity is pulling down. But we need to find the force of gravity first. Well, force of gravity is mass times gravity, so that's 2,000 kilograms times 9.8 meters per second squared, the acceleration of gravity. If we multiply those two numbers, it comes out to be 19,600 newtons. So now, knowing our two values, tension and force of gravity, we can find the net force from that. One pulls up, one pulls down. Because they're working in opposite directions, two vectors in opposite directions, means we have to subtract the two. So 19,600 newtons minus 18,000 newtons is 1,600 newtons. And the direction is important as well. Fg is bigger than Ft, so that means that the net force is down. Now we can use that in our equations, so 1,600 newtons equals mass. The elevator has a mass of 2,000 kilograms, and we use that to solve for the acceleration. So we do our math, 1,600 divided by 2,000 gives us an acceleration of 0.8 meters per second squared, and this elevator is actually accelerating down because, again, the force of gravity is larger than the tension.